We are looking at indices. We are looking at indices. Indices is the study of powers. Indices is the study of powers. Just like 2 power 4, x power 2, and etc. Study of powers. But when you connect indices to exponents, this takes us to even unknown powers. You can have 2 power x, 3 power p. So indices and exponents, we deal with the powers. So powers can have numbers or powers can have letters. But we have some laws that govern the use of powers. We have laws that govern the use of powers. I've listed a few of them, which are basic and very important in most of the times. The first one tells us that if you have got same base multiplying, the law says just add the powers. Take one of the base and add the powers. And the same place, if you have same base dividing, the law says take one base and subtract the powers. The next law says if you have got a base and a power, then we have brackets and we have another power outside the bracket. The law says those powers, the powers which are inside, will always multiply with the power which is outside. Even if inside you have got more than 2 powers, and then outside we have 1 power, this means the power which is outside will always multiply both powers which are inside the bracket. Then the law, another law states that for a square root, we can directly change it to power a half. So this continues by saying if it is a cube root, we can also change it to power 1/3. So n stands for any root, cube root, 4th root, 5th root, 6th root. It can change to 1 over that. So that is one of the important rules to remember when you are dealing with indices. Another rule is that when you have a number with a power, if that number with the power is a numerator, if that number with the power is a numerator, you can directly change it to become a denominator by only changing the sign of the power. If the power was positive, change this to become a denominator and make the power negative. Then this statement will be exactly the same as this statement here. Or if the power was negative here, then when you take it to the denominator, this power will change to become positive. And vice versa is true. If you have got a denominator, you can change it back to the power or to the numerator, but also the power will change sign. Last but not least, if you have got any number to the power 0, it is always equal to 1. Even if it is 1 million to the power 0, it is always equal to 1. We can even test it by using a calculator there. That if I have 6 to the power of 0, see, 6 to the power of 0, I press the button for answer, it tells me the answer is 1. So that's a basic law, that any power 0, change the whole question to 1. And the vice versa is true. If I have 1, I can change it to any number power 0, right? If I have 1, I can change to any number power 0, that is in indices. Having looked at those important 6 rules, let us use those rules to do some questions. Let's start by simplifying. Simplify the following. So this one is basic. So I take m for I plus 2 because they are base and they are multiplying. So when bases are multiplying, I add the powers. And my answer would be m power 6. Next, if you check properly, this question is the same as dividing. So if one is up, one is down means they're dividing. So I would take the powers and I subtract them. And finally, I get p power 3. Now, this is another important trick. This number does not have a power, but we can change this number to write it as its product of prime factors. We change the number to its product of prime factors. By 2, I get 16. By 2, I get 8. By 2, I get 4. By 2, I get 2. And by 2, I get 1. So this number now can be written as 2 to the power 5. So I change my question. I write this 2 to the power 5 and 2 to the power 2. So that's what you have learned right now, that whenever you have a big number, changes to its product of prime factors. Then continue. The next rule here, if you remember them, change the square root to power half. After changing the square root to power half, so now we have got powers inside and powers outside. This means the powers inside will multiply with the outside power. In this case, we shall get 2 power 2.5 here, and here we shall get 2 power 1, which remains as 2. Another person would write this 2.5 and p is fine. In indices, you are not allowed to square root 32 because it takes it to decimal. In indices, we like to deal with powers. So change your big number to a product of its prime factors. Let's look at another example here. So here is 2a. If this is down, I can bring this one down there as well, so that I get like that. When it was up, it was power -3. But now I took it down to the denominator, the power has changed to positive. Then finally, I have to subtract the powers because the question is dividing. And when I subtract the powers, I get -1. We are advised in the laws of mathematics and indices, if you can write your answer to have positive power, then that will always be the best solution. So when we end up to the power that is negative, then use the same law to take it up, and then it will be power positive, and we shall write our answer as A. When you look at the next question, we have 1,000. The law has taught us that if you have a big number, change that number to its product of prime factors. So I start. By 2, 500. By 2, 250. By 2, 125. By 3, impossible. So I go to 5. By 5, I get 25. By 5, I get 5. And by 5, I get 1. So when you look at this question properly, it will be 2 power 3 times 5 power 3 here. So I have written this number to its product of prime factors. So I go to the question and I write 2 power 3 times 5 power 3 times n power 6. So next step, I remove the square root and I keep the power 1/2, because as we said, one of the rules, we remove square root and keep a fraction power. Then we said, you multiply, no need of bracket anymore, 3 times the power, sorry, it was cube, not square in the question. So meaning it becomes power 1/3, not square So here we have 1 over 3 times 5 power 3 times 1 over 3 times n power 6 times 1 over 3. So this makes it gone. So I get a 2 times gone. I get a 5 times by 1 by 2, I get n squared. So now 2 times 5 is 10 and n squared. So that's how we mathematically follow indices to simplify that question. Now let us solve for x. In indices, let us solve for x. Again, I have a big number. In order for me to do indices, I need to deal with same bases. I need to deal with same base. So I need to change 16 and write it as a product of its prime factors. And that will be 2 power 4. So my new question would be 2x is equal to 2 power 4. So basically, since this side the base is 2, and this side the base of 2, and they're equal, means even the powers should be equal. So therefore, 2x should be equal to 4. So I divide by 2, I divide by 2, and my x is equal to 2. In the same way, here, this is the denominator. I change it to become numerator, I'll get power negative x, because the law has told us if you want to put something from denominator to a numerator, the power will change sign. And in this case, our power was positive x, but when I take it to the numerator, it will become negative x. 27, I change it to base 3, and it will be 3 power 3. Because 3 times 3 is 9, 9 times 3 is 27. Now, base is the same, powers should be the same. So negative x should be equal to 3. I divide by negative 1, then my x is negative 3. Last but not least, when you look at the first part, our base is 5. So that means I change all the other bases to become 5. So that I have same base and I deal with same base. 25 is the same as 5 squared. Now we are going to apply the other 6's law. When you have 1, we said it is the same as any number to the power 0. Now because I need base 5. So I will change 1 and it will become 5 to the power 0. So that I have everything to the base of 5. Okay, now look at this part here. We said when you divide, you subtract the powers. So that means 5 to be x minus 2 is equal to 5 power 0. So when this side, the base is the same as that side, therefore it means even the powers will be equal. The power of that side will be equal to the power of this side. Hence, I take my 2 to the other side and I get my x as positive 2. So this is how we deal with indices when we want to solve for any question. We conclude by reminding ourselves that we have got 6 important rules that we need to remember all the time. Why all the time? Because we can have one question which is combining 2 to 3 or to 4 rules at the same time. So you don't need to forget any rule of indices. Remember the rules. Remember the last law about 1, when 1 can be changed to any base but power 0. Thank you for being a good audience. You can subscribe to my channel for more videos. My name is Mr. Ishengoma.